All right, so the third case for horizontal asymptotes actually doesn't produce a horizontal asymptote, all right? It doesn't produce a horizontal, it actually is going to produce a oblique asymptote or a slant asymptote. Basically something with, kind of an angle to it, that's all. Now, if we look here, we'll notice the third case is a kind of an odd case, but it's when the degree of the numerator is exactly one more than the degree of the bottom. So here it's a 2 and a 1. It could have been a 4 and a 3 or a 5 and a 4, just so long as the numerator has a higher degree just by one value, all right? So this is going to involve a slant or oblique asymptote, all right? Now, if we go ahead and look at a picture of it, you can see it's kind of odd shaped already, but what we see here is off towards negative infinity, it looks like it's following a linear equation. It looks like it's following some straight line. And if we look towards positive infinity, it's doing the same thing right here. Right? Off towards positive infinity, we see that it's growing at the same rate. So what we're going to do this time is find out what that line is. And it's pretty simple. All you do is a little division. You can use polynomial division or synthetic. And of course, we're going to use synthetic. So we'll set up our outside number is 4. Okay, because that's what drives the denominator. That's what drives that factor to 0. And inside, we'll have the coefficients 1, -1, and then -6. All right. Bring down the 1. 4 times 1 is 4. Add those, and you'll get positive 3. Multiply those, and you'll get 12. And then our remainder here is 6. All right, so if we translate this to our new polynomial, it will just be 1x plus 3. Now this remainder part actually doesn't matter. This is going to be our, not HA, but it's going to be our oblique asymptote, all right? So if we look at that graph again, the line that this thing is following here is actually x plus 3. Let me show you here in the graph, y equals x plus 3. See how they match up. They're completely parallel off towards infinity here. Okay? So we find that oblique or slant asymptote just using some division here, and we kind of forget the remainder. So we lop off the remainder. The last thing I'll do here is I'll try to kind of gauge what our range is for this function. All right, so definitely negative infinity. All right, it's coming from negative infinity. And then it has a jump right here where it skips these y values, and then it goes off towards positive infinity again. So our range is going to be negative infinity to some value, all right, and then union with some value to positive infinity. Okay. Our lower bound here is actually 2.101, and in this case, it actually reaches that point. Right? It's not there's not like a vertical asymptote there to where we can't cross it. 2.101 is actually defined on this. So 2.101, and that will be included this time. And on the bottom here, the upper is going to be 11.9, I guess. And you'll see that is actually included. So that'll be 11.9 to infinity. And that should be a bracket too, I'm sorry. There we go. So this function is defined for all values except for the values between 2.1 and 11.9.